This is Unit 4, Lesson 6. Today we're going to be learning how to divide polynomials, and we're going to learn how to do division using long division. In this section, dividing polynomials is just kind of an extension of what we did with monomials before. We learned in the last lesson that if you have something like 25x squared y cubed z to the fourth over 10x cubed y to the second z, that if we simplify that, we're going to simplify it by division. And basically what you do is you're going to take the 25 over 10 and you're going to simplify that fraction. So 5 goes into both of those, so that would be 5 halves. And then you're going to simplify the variables. Here we've got 2 x's and 3 x's. The 3 is bigger, so 3 minus 2 is 1, and the leftovers go on the bottom. For y cubed and y squared, we've got 1y left over on top. And for z to the fourth and z to the first, we've got 3 z's left over on top. So for this monomial, the answer would be this. Well, we're going to extend that thinking a little bit to a polynomial divided by a monomial. And really all you do here is, it's like doing 3 separate problems of this. You're going to take that monomial that's on the bottom and you're going to divide it into each of these terms separately. And you'll have a trinomial or a polynomial for your answer that has the same number of terms that your numerator had in the beginning. So if we solve this polynomial, what I'm going to do is I'm going to take the 5ab and I'm going to divide it into each of these terms separately. So if I do that, 5 goes into 5 one time, so they drop out. A squared divided by a is an a to the first. That a would be on the top because the 2 was bigger on top. B goes into b, it cancels, so that's going to be gone. Whatever sign is here, we're going to put in the problem. 15 divided by 5 is 3. The a's drop out. We have 2 b's left over. Everything's still on top. For this one, 5 goes into 10 twice. I keep the plus. A cubed over a would be a squared. B to the fourth over b would be b cubed. Now, all of your answer here is on the numerator. It's understood to be over 1. We don't need the 1 because when we're dealing with fractions, anything over 1 is the same thing as just the numerator. So we don't need to put the 1 there. I would always encourage you not to put the 1 because when you do, it's not technically in the simplest possible form. So we always want to leave the 1's out if it's possible to leave them out. So that would be my answer for this one. You may have occasions where some of the exponents are higher on the bottom than they are on the top, so I want to show you how to deal with one of those. So here's another example. It's very similar to the last one. We're going to take what's underneath and divide it into each of these terms separately. And if you look at what we've got here, 18 over 6 would be a positive 3 on top. X cubed over x to the fourth. Well, this time the x is bigger on the bottom. So we're going to have 1 left over, and it's going to be on the bottom. And then we've got y and y to the fourth, so we're going to have 3 y's left over on top. So it's okay for one of your terms, or all of your terms even, to have a fraction left over. That's okay, there's nothing wrong with that. Then we're going to put whatever sign is there between. 9 over 6, if you simplify that, 3 goes into both of those, so that would be 3 halves. So again, we have something on the denominator, that's okay. X to the fourth over x to the fourth, they cancel. Y squared over y is going to be 1y on top. And then we keep the minus. And then 24 divided by 6 is 4 on top. X over x to the fourth, that's going to be 3 x's left on the bottom. And then y squared over y would give us 1y left on top. So really this is nothing more than the distributive property, but instead of multiplying to get our answer, we're dividing to get our answer. It's very similar to the distributive property. In this segment, we're going to talk about how to do long division. Doing long division using algebra is very similar to what you learned in elementary school when you did long division. If I have that problem 2097 divided by 6. When I divide 6 into 2097, the first thing I have to do is take the 6 and try to divide it into 2. Well, we know 6 doesn't go into 2. So if it doesn't go in, we do the next number with it. 6 goes into 20 3 times. Now, wherever the 6 or wherever the place value is that I ended with or started dividing into is where my number goes. So 3 will go over top of the 0 because that's the last digit that I was dividing into, okay? So 3 times 6 is 18. Then we are going to subtract. 20 minus 18 is 2. Now 2 is less than 6, so we know it doesn't go in anymore. We know we've got the right number up there. And then I'm going to bring down my 9. Then I do 6 into 29. 6 goes into 29 4 times. 4 times 6 is 24. We subtract. 29 minus 24 is 5. 6 does not go into 5, so we're okay to go ahead and bring down the next term, which is 7. 6 goes into 57 9 times. 9 times 6 is 54. And then when we subtract, 57 minus 54 is 3. My remainder, remember, you can write that remainder. When you first started doing division, you did R3, remainder 3. Well, then hopefully you learned as you got further along in math that that remainder can be written as a fraction. And that's what we're going to do in algebra. We have to write everything in terms of the whole number, or the whole part, and then its fraction part, the fraction of the answer. So what I do is I take this remainder and put it over my divisor. So that would be 349 and 3/6. So I can simplify that as 349 and 1/2. That is my answer. So when I have a remainder, I'm always going to put that remainder over top of the divisor, and that will be part of my answer. In fact, when we're dealing with the variables, we won't just put it right beside the number. We'll say plus that remainder, or plus that fraction. And essentially, isn't that what this is? 349 plus 1/2 is 349 and 1/2. So when you're dealing with numbers, it's just a little bit different than dealing with variables. This one, if I could factor this one to get the answer, that's what I would prefer you do. But I'm going to show you how to do long division with easy problems first, because if you can do it with easy problems, the difficult problems really aren't going to be that bad. They're just going to look a little bit different at the end. Okay, so if you think about this problem, we've got z squared plus 2z minus 24 divided by z minus 4. So if you think about that, isn't that the same thing as z squared plus 2z minus 24 over z minus 4? And earlier in the chapter, didn't we learn how to simplify algebraic fractions? We factored. Factors of 24 that subtract to give you 2 are 6 and 4. And the 6 gets the plus, and the 4 gets the minus. And so then we have the z minus 4 on bottom. So the z minus 4's cancel, leaving us with z plus 6. So z plus 6 is what we should get when we do this one using long division. The problem with doing it this way is, what if we had a remainder? If we have a remainder, it's not going to factor. And if it doesn't factor, we have to have another way to do it. Okay, so I'm going to show you first a couple that don't have remainders so that you can see how that works. And you can see that actually factoring would be the best method to use here. If you can use factoring, that's what I would suggest you do. So as you get examples, if you can factor to get the answer, I would do that first. I would only use long division when, first of all, they tell me to use long division, because it probably is the most difficult division method when you're dealing with algebraic fractions. So I would only use long division if you're told in the directions that you have to use long division. Okay, it's not probably the most efficient method, but it is good to understand how it relates to doing it with numbers. Okay, so if you look at this, if I'm going to do this one using long division, remember long division, we have the division symbol. And you need to understand what goes on the inside and what goes on the outside. This would be what we're dividing into, so, or the top number, if it were a fraction. So that goes on the inside. And then we're going to divide that by z minus 4, so that goes on the outside. Also, another thing you need to realize is if you have a polynomial, every term in that polynomial has to be accounted for. So let's say this started with a z cubed, and then went to plus z squared. Well, if this were z cubed, I would have to add a plus 0z squared plus 2z minus 24. I couldn't leave out any of the descending terms. I'll show you one like that in a few minutes to make sure you understand what I'm talking about there. But then when I'm dividing this, it's really pretty simple to divide. What you're going to do is you're going to take the first number in the divisor, or the first variable, whatever it is. You're not even going to worry about this one, okay? So you're going to take the first term there, and you're going to divide it into the first term here. So if you think about that, z squared divided by z. Well, that's just z. So up here, I have a z. So if I take z and multiply it by this, and I'm going to distribute the z with this entire divisor. So z times z is z squared. Z times negative 4 is minus 4z. Once I've done that, then I subtract. So I'm going to subtract each of these terms from each of these terms. And they have to be like terms, remember, in order to subtract, which is why I can't leave out any of my descending terms. Okay? So if I do that, z squared minus z squared is 0. We don't need to write the 0, but that's what should happen if you did it right. If that doesn't cancel out, you did something wrong. Okay? And then 2z minus negative 4z. Well, that's 2z plus 4z, which is 6z. Once I've done that, then I can bring down my next term, and I bring down the minus 24. Then I'm going to do the same thing. Z divides into 6z, so 6z over z. Well, how many times does that go? It goes 6 times. So I'm going to put a plus 6. If that were a negative 6, I would put minus 6. So the sign depends on what you end up with here. Then I'm going to distribute. So 6 times z is 6z. 6 times negative 4 is minus 24. I'm going to subtract. 6z minus 6z is 0. Negative 24 minus negative 24 is 0. My remainder is 0. My answer is z plus 6, the same thing we got here. So here I've got two more problems. One of them is one of the simpler problems. That x minus 5, remember, it's to the negative first. So that negative tells me I move it to the bottom as a positive. And then my x minus 5's cancel, leaving me with x plus 3. So if I do this problem using long division, I should get x plus 3. Remember, you're only using long division if they tell you have to. But if you have something simpler that will work and they don't specify to use a certain kind or a certain method, go ahead and do it the easiest way, the most efficient way possible, okay? Most of the time if they ask you to do long division, you're not going to be able to do it this way, okay? So let's do this one using long division to make sure you understand how to. So that's x squared minus 2x minus 15 divided by x minus 5. So x goes into x squared x times. X times x is x squared. X times negative 5 is negative 5x. I'm going to subtract. Then x squared minus x squared is 0. Negative 2x minus negative 5x. That's negative 2x plus 5x would be a positive 3x. Then I'm going to bring down my minus 15. Then I do that again. X into 3x. Well, x goes into 3x a positive 3 times. Then I multiply. 3 times x is 3x. 3 times negative 5 is negative 15. If I subtract, 3x minus 3x is 0. Negative 15 minus negative 15 is 0. My remainder is 0. That means my answer is x plus 3. Here's an example where it is not a factorable problem. 3, are there factors of 3 that add to give you 5? No, there are not. So the only way to do this one so far that we know is to do it using long division. So I'm going to take this one and I'm going to put the a squared minus 5a plus 3 underneath my divisor. Remember, this is what I'm dividing by because it says negative 1, that would be on the bottom. So I'm going to put the a minus 2 here. And so I'm going to do long division. A goes into a squared a times. A times a is a squared. A times negative 2 is negative 2a. I subtract. So if we have a squared minus a squared, we get 0. Negative 5a minus negative 2a is a plus 2a. So negative 5a plus 2a is negative 3a. I bring down my plus 3. Okay? And then negative 3a divided by a minus 3. Negative 3 times a is negative 3a. Negative 3 times negative 2 is a positive 6. I then subtract. So negative 3a minus negative 3a, that's negative 3a plus 3a, cancels. 3 minus 6 is negative 3. So this one has a remainder. So remember, when we did the long division with numbers, our remainder went over top of our divisor as part of our answer. Since this is a minus 3, we're going to say that this is a minus 3 over our divisor, a minus 2. This would be my answer. So I'm just going to do a couple more long division problems to make sure you got it. With this one, are there factors of 9 that subtract to give you 3? There are not. So when I set this one up, I've got t squared plus 3t minus 9 divided by t minus 5. So now that it's set up, I want you to go through, pause the video, see if you can get this one on your own. Okay, so for this one, I'll take t into t squared. It goes t times. When I distribute, I get t squared minus 5t. When I subtract, I end up with 8t. Then t goes into 8t plus 8 times. I distribute, get 8t minus 40. I subtract. The 8t's cancel. Negative 9 plus 40 is 31. So I end up with a remainder of 31. So it's plus 31 over t minus 5. Leaving me with this answer. Earlier I had mentioned that if you have any terms that are missing, you have to include them in your dividend. If you look at this one, we've got x to the 5th. Our x to the 4th and x cubed terms are missing. If that happens, I'm going to have to account for them in this portion of my problem. So to rewrite this, I'm going to write x to the 5th plus 0x to the 4th plus 0x cubed minus 3x squared minus 0x, the x term is also missing, minus 20. My divisor is x minus 2. So look at what leaving out terms does to our long division problem. It makes it quite a bit more difficult. You don't tend to see these very often, but I want to make sure I show you how to do them just in case they do show up in any of the work that we're doing. So you're still going to do the same thing. The process is exactly the same. So if I put x into x to the 5th, I get x to the 4th. X to the 4th times x is x to the 5th. X to the 4th times negative 2 is negative 2x to the 4th. The reason I need to include the zeros is because when I do the distributive property, if I hadn't done that, then I would end up with x to the 4th underneath a negative 3x squared, and you can't do that. So that's why I need to include my zeros. So if I subtract, the x to the 5ths cancel, 0x to the 4th plus 2x to the 4th is 2x to the 4th. I bring down my 0x cubed. Now x goes into 2x to the 4th, a positive 2x cubed times. I distribute. 2x cubed times x is 2x to the 4th. 2x cubed times negative 2 is negative 4x cubed. Then I subtract. The 2x to the 4th cancel. 0x cubed plus 4x cubed is 4x cubed. I bring down my negative 3x squared. X goes into 4x cubed, positive 4x squared times. I distribute. 4x squared times x is 4x cubed. 4x squared times negative 2 is negative 8x squared. I subtract. The 4x cubes cancel. You see the pattern here. If you're doing it all right, your first one's always going to cancel. Negative 3x squared plus 8x squared is 5x squared. I bring down the minus 0x. X goes into 5x squared, a positive 5x times. 5x times x is 5x squared. 5x times negative 2 is negative 10x. I subtract. 5x squared minus 5x squared is 0. Negative 0x minus negative 10x is a positive 10x. I bring down my negative 20. X goes into 10x, a positive 10 times. 10 times x is 10x. 10 times negative 2 is negative 20. And look at what happens. We end up with a remainder of 0. This would be our polynomial. Okay. Now, some of you might say, well, why didn't we factor that one? Well, have we talked about how to factor something to the 5th power? We have not. So if we were to try to learn how to factor that, you're going to have to either know how to do long division or synthetic division. I would prefer synthetic division because it's easier. But this just gives you something else to see. You know, if you are missing terms, you have to include them in there, otherwise your long division isn't quite going to work.